and this is y. So all the plates are identical. So let me write this separation d and let it be 2d. They need not be equally separated. All the plates are identical. So we want capacitance xy. Don't go for Gauss law. You'll be really in a big trouble. Just construct a system. So there are how many plates are there? So you give number for them. The plates, numbering of plates, you do it. So this will be 1, 2, 3. So this is x. From x to the plate 1. Between 1 and 2, there will be a capacitance, no? So you write 2. And from 2, what happened? It has to the y. Then again, between 2 and 3 is connected to x. So you draw like this. This is 3. And 2 is connected to y. So now biggest trouble for students are how many plates are there? 3, you're drawn 4. No, the plate 2, what will happen, will be common for both 1 and 3. It is having two surfaces. One surface will interact with 1, other surface will interact with 3. There'll be interaction between these two faces. There'll be interaction between these two faces. Like this, you redraw circuit. Then bring that separation. So between 1, 2, the separation is d. Between this is 2d. This is very important. Even in SU or yes, stress this one. So how they're parallel. So the effective capacitance will be Cxy equal to C12 plus C32. This should be epsilon naught A by D. This will be epsilon naught A by 2D. So 3 epsilon naught A by 2D. If they trouble you with, here I'll apply EMFE, then what is the potential drop across 1, 2, what is the potential drop across 2, 3, directly don't look at here, come to this circuit. How this two are parallel, they must have same potential drop. So even I'll just bring some conditions in the circuit. Let me connect to a cell. What is the charge at all surfaces? So nothing but you are going to bring a cell here. Okay, fine. So the cell is what you are going to bring it here. So can't you find out charge? No? Yes, it will be. So what are the charges? Charges will be here. You can write it some Q minus Q here Q. Should be same or different. Capacitance are different. Charges must be different. So what is the net charge on the plate 2? The difference you have to take out this particular thing. So what is the charge? Q should be equal to epsilon naught A by 2 into E. What about this? This should be equal to F naught A by 2D into E. Now what is the net charge of plate 2? Should be some value, and the charge on plate 1 and 3 will be different. So they may trouble you with any of this question. Now just only this. Further they may ask you charge. Like this, some n number of plates, different configuration. Let me give one more.